The goal of this project is to develop a method for creating computer animations that combines the control of using keyframes with the rich detail that can be achieved using motion capture data. Our technique allows an animator to sketch out an animation with a small number of keyframes for a few degrees of freedom and then enhance the resulting animation with motion capture data. For the degrees of freedom that have been keyframed, the resulting smooth curves are textured based on information in the motion capture data. Degrees of freedom that have not been keyframed are synthesized. We divide our process into several steps: frequency analysis, matching, pathfinding, and joining. First, the animator chooses the degrees of freedom that will drive the rest of the animation, often joint angles near the root, such as the hip and knee angles. We will refer to these degrees of freedom as the matching angles. Usually more than one degree of freedom is chosen, but in the following presentation, we will illustrate the process for just one. The matching angles for both the keyframe data and the motion capture data are decomposed into frequency bands, and one of the lower frequency bands is used for the matching step. This band is broken into fragments. We step through each of the fragments of keyframe data one by one. Each is compared to all of the fragments of motion capture data, and several of the closest matches are found. A degree of freedom is synthesized by choosing fragments of data from the same location and time where the fragments of low-frequency data found in the matching step came from. The best paths are found through the fragments, and the ends are joined smoothly in the final step. A degree of freedom is textured by exactly the same method, but only the higher frequency bands are created, replacing the higher frequency bands that were already there in the keyframe data. Here we show a sketched out animation of two characters. We enhance the motion of each character with motion capture data of a different walk style. The final animation not only is more detailed and lifelike, but clearly captures the different motion styles found in the two data sets. The motion in the enhanced animation looks correct, even though the keyframed animation contained other motions, such as steps that get smaller and smaller, and a stomp. Our method can also be used to alter the style of an existing animation that may already have a large amount of detail in it. Here we show a keyframe animation that has been created by professional animators. Using motion capture data of one of the two walk styles shown earlier, we can change the style of the character's motions by texturing the upper body degrees of freedom. The technique can be used to synthesize missing degrees of freedom, even for complicated full body motions. Here we show a keyframe sketch of a character doing some modern dance. Given some motion capture data of dancing, an example of which is shown here, we can enhance the keyframed animation. Here the upper body motion of the purple character was synthesized based on the keyframed lower body motions. The motion of each leg was textured when it was not in contact with the floor. Here we show an animation created by the same method, but in which we kept two different paths through the possible matches for each fragment. We see that the resulting motions are different, but both are valid. Another way to create different animations by this method is to use different degrees of freedom in the matching step. For example, in this animation, the upper body motion of the blue character was synthesized using only the left hip and left knee X angles as the matching angles, while that of the purple character was synthesized based on all of the angles of the left and right hips and knees. Notice that the resulting animations are quite different, but in both cases the upper body is coordinated with the lower. Ultimately, the matching angles and paths are parameters that the animator can manipulate to achieve the final animation.